Okay, we're going to fill in 3 different sections of the ISM, starting with 12.5 volumes of pyramids and cones, which we did yesterday. The figure shows a prism and a pyramid that have the same base and the same height. It's clear, hopefully, to you that the volume of the pyramid is less than the volume of the prism. More specifically, the volume of the pyramid we found out yesterday was 1/3 the volume of the prism. Therefore, what we do to find the volume of a pyramid is we take the area of the base times the height divided by 3. What it's going to look like on your formula sheet for final exams will be base area times height divided by 3. And there is a key for what the big B stands for on the formula sheet, which I've run off for you. Next, just as with prisms, if a pyramid is oblique, meaning it's leaning, then the volume formula is the same, though the height must still be perpendicular to the base. So the height's in a weird place compared to this one. This one's right smack in the middle. This one's not, and it could even be outside. So find the volume of the square pyramid. This area, this base, is what the big B stands for. Okay, so the base area would be 8 times 8, which is 64 square feet. The height is the 10. And the volume then would be about 64 times 10 divided by 3. That is a 4. Grab our calculator and type it in. Apparently my calculator is not wanting to work. Here we go. Okay, 64 times 10 divided by 3. Okay, we got 213.3 repeating cubic feet. Second example, find the volume of each pyramid, round the answer to the nearest tenth if necessary. Okay, the base of this pyramid, which is oblique, or leaning, base area would be 15 times 15. This thing thinks I'm... Did it happen in this class too? Yeah, today, twice, same classes. I don't understand. I just turn it off. Stupid phone. All right. I think I must have said something that sounded like Siri. I have no idea what it was. All right, 15 times 15 is 225 for my base area. Now my volume, area of the base, 225 times the height, 16 divided by 3. Okay, I don't know what that is, so I'll just go ahead and type it in. You've already done, oh, good for you. You already did it. Okay, 1,200. Anybody having a problem with finding it to be 1,200? By the way, again, like any other time, you should be practicing typing these in. You will find out that you'll make a lot less mistakes when you take the quiz. All right, the next one, its base is a regular pentagon. Okay, the area of the base is going to be apothem times perimeter divided by 2. That is the formula. The apothem is this 4.1. So I'm going to do this base area first, and I'm going to show all the work. I got to find the perimeter. Well, the perimeter is 5 sides, and each of those sides is 6. It's showing that it's regular. So the perimeter here would be 5 times 6, which is 30. Okay, so I do 4.1 times 30 divided by 2 to get the area of my base. So I'm going to grab my calculator and do that now. 4.1 times 30 divided by 2. 61.5 for my base area. Okay, now to do the volume of the prism. Volume is area of the base, 61.5, times the height, which is the 11, divided by 3, because it's pointy, a pyramid. So on my calc, I type 61.5 times 11 divided by 3. Okay, got 225.5. What was it, 221.5? 225.5. Oops, thank you. And that was in cubic yards, or yards to the third, yards cubed, whatever you want to say. All right, the next one is a triangular pyramid. Its base is a right triangle. The area of the base is going to be little b, base times height divided by 2, because that's the formula for the area of a triangle. Now that triangle, the legs would be the base and the height. Whenever it's a right triangle, the legs are the base and the height. So our base area will be 6 times 8 divided by 2. That's 48 divided by 2, which is 24. Now we can do the volume. It's area of the base, 24, times the height, 7, divided by 3. You can do this in your head by doing 24 divided by 3 is 8, and then 8 times 7 is 56, and that's if you know your times tables well. Otherwise, just type it in. 56 cubic miles. That's one ginormous triangular pyramid. That the next page in your ISN has cones on it. For a cone, the volume is also 1/3 the product of the height and area of the base. The base of the cone is a circle, and the reason this is what it is because it would take 3 of these cones to fit inside a cylinder. With this, you don't have to draw this. I'm just reminding you. That's why it was 1/3. Remember, the cylinder was area of the base times the height? Well, the cone is 1/3 of that. Don't need to draw that. Just reminding you where it came from. If a cone has a volume of v cubic units and a height of h units, the bases of the bases have a radius of r units. Oh, this shouldn't say bases. Well, depends on which cone it is. Then the volume is pi r squared times the height divided by 3. Find the volume of this cone. Volume is going to be pi. The radius here is 5, so we do 5 squared, times the height, which is 12, and then we divide by 3. So second pi times 5 squared times 12 divided by 3. Type it all at once. Got 314.2. Did I put the right numbers in? Yes. 314.2 cubic centimeters. Next example. This cone is just laying sideways. It has a diameter of 20, therefore the radius would be half of that, 10. The height's missing. So I need to know it, else I can't do the volume. Well, this heights are always perpendicular to their bases, so we have a right triangle here. It has a leg of 10, the height is the other leg, and the hypotenuse is 26. So we're going to need to do Pythagorean theorem. H squared plus 10 squared equals 26 squared. 10 squared is 100. 26 squared is 676. We subtract 100. H squared equals 576. We take the square root of both sides. And when we take the square root of 576, we get 24. So the height is 24 feet. Now I can do my volume. Volume is area of the base, pi times the radius squared, and the radius is 10, so pi times 10 squared, times the height, which we found to be 24, and then we want to divide by 3 because it's a cone. What was the, 24, and then divide by 3. 2,513.3. cubic feet. Okay, number 7, the radius is given and the height. So we're ready to go for the volume. Pi times 6 squared times 12 divided by 3. Six squared times 12 divided by 3. Okay, so for that one we got 452.4. Yes. Right. Cubic centimeters. Okay, that should be it. Oh, rotating solids. Wanted to talk to you about what these shapes make. If you take a triangle and you spin it around a vertical or even a horizontal line, you've got a horizontal line here, your shape is going to be a cone. I just did one vertically as well, just to give you an idea. You don't have to draw the vertical one. If you take a rectangle and you spin it around, you're going to get a cylinder. You could do it this way too. So if you had like one, say there was just a little rectangle there, and you decide to spin that piece of paper around, it's going to go back and come out to the front. And it's going to do that at the bottom and the top, a whole piece of paper, and that's where you get that cylinder. Makes a shape of a cylinder. Okay, that's it for that ISM. That was the 12.5. Let's go to the spheres ISM, please. Got some stuff to cross out. Okay, we used to add in the surface area. We're only going to do the volume. So let me just erase this and I'll just show you what you need to chop off. So it's quite a bit. So I'll explain why. It's definitely not on the final. And then I'll tell you what is. Okay, I'm sorry, I meant to get one that wasn't written on, and I accidentally still had 4th hours or some other hours up here. Okay, boom, 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 boom. Now you can see there's quite a bit canceled out. And let me explain why. Surface area we are not going to be doing. It is something that we could have covered, but it's not in the final, so we're just going to get over onto what we need to have covered. It's just a formula where you plug in and get, so we can cross this part off. We will be doing volume. You will not get to use your ISN on the final anyway, but you'll have the formula that you need. The surface area question can get crossed out then. And so can 2 and 3. Save us a little time today. But what we do need to know is the volume. So this is not getting crossed off. A sphere has one basic measurement, and that's the length of its radius. If you know the length of the radius of a sphere, you can calculate its volume. We will use 4 times pi times the radius cubed divided by 3. So, examples. This sphere has a radius of 8. Find the volume. It's 4 pi times 8 to the 3rd power divided by 3. Got to help you with typing that possibly because some of you may not know how to cube it. 4 pi. We got down how to calculate that. Now we've got to do 8 to the 3rd. So how you put that in, you need to arrow up. You see that under clear, there's an arrow. Press that. Everybody better practice this, else you could mess it up on the final one. How could you possibly want to miss a question that easy when all you're doing is plugging something in? Okay, put in the 3. Most of us have these new calculators. The OS operating systems have been adjusted since the olden days. So it also can do crazy things like things that you need to do in Algebra 2. So we need to get out of the exponent. You got to arrow out, else you're still up there. And if you type more stuff, then it's going to look crazy. All right, so 4 pi times the radius cubed. What's the next part of the formula? Divided by 3. Okay, so hit divided by 3. All you can do is type this all in at once, and bang, 2,144.7 cubic centimeters. Right? And that's where that answer was, so ignore that line on my paper. Find the volume of each sphere or hemisphere. A hemisphere is half of a sphere. I think you can tell that by looking at the picture. You know there's a southern and a northern hemisphere to our world. You've heard that before, right? That's what it is. It's half the world, top and bottom. All right, so volume, 4 pi times 5 to the third divided by 3. 4 pi times 5 to the third. Arrow up, put in the 3. You better arrow out. If you hit divided by 3, look what happens. Uh-oh. Messed up. So you can hit clear and it'll pop back, and then you can put it back in the 3. Then you arrow out of there, hit divided by 3. Okay, 523.6 cubic feet. Okay, and then number 6, 4 pi times 6 to the third divided by 3. But it's only half of a sphere, so we actually need to divide that answer by 2. So do it then. So go with 4 pi. We can just do it all at once. Times 6, arrow up to the third, get out, divided by 3, and then divide by 2 after that. And it looks really weird when you type it like that, but it works. It's 452.4. Anybody not getting 452.4? Oh, you did? Okay. Cubic inches. I think that's all we are. Actually, the rest of this, the density, we're not doing density, so you can cross that part off, as well as the very last question. So what we want to move to now is the 8 ISN. Uh-oh. I think I forgot to erase that one. I'm going to pause a second. Okay, so 12.8 is volume and surface area of solids. Oh, I forgot about this part of it. Hello. And that's when we're determining whether things are similar or not. Get that out of there. Okay, if something is similar, we've learned from another chapter that their corresponding sides must be in the same ratio. So this isn't altogether new. Similar solids have exactly the same shape, but not necessarily the same size. Okay. Two solids are similar if they have the same shape and the ratios of their corresponding linear measures are equal. Got to have the same shape and ratios equal. All spheres are similar to one another, and all cubes are similar to each other. Congruent solids have exactly the same shape and the same size. Congruent solids, similar solids with a scale factor of 1 to 1. If they're congruent, then they're going to have angles, edges, faces, and volumes equal. All of those things would be equal. Determine whether the pair of solids is similar, congruent, or neither. If the solids are similar, state the scale factor. So what you have to do is you have to go and you have to check if all of the things are proportional. So you go, all right, 2 is to 4. That's the one they're looking at right here. It reduces to 1/2. You don't have to worry about whether you color code this or not. I'm just trying to show you where they're getting this from. The length would be the 4 here and the 8 here. So they did 4 over 8. That would reduce also to 1/2. The ratio of the hypotenuse, that would be the 6 and the 12. So that's 6 to 12, which also reduces to 1/2. And then finally, the heights, 4 and 8, there and there, are in the same ratio, 1 to 2. Since all the ratios of the sides are equal, that means the triangular prisms are similar, and the scale factor is the 1/2. Since the scale factor is not 1 to 1, they're not congruent. Okay? So we're going to determine whether each pair of solids is similar, congruent, or neither. All right, so I'm going to start comparing the numbers. I've got 3 to 9. That reduces to 1/3. I've got 4 to 12, which also reduces to 1/3. And then I've got 2 to 6. That also reduces to 1/3. So all of the ratios of the corresponding sides are the same. So the scale factor is 1/3. If the solids state the scale factor, that's what we want. The scale factor is 1/3. Number 2, we've just got the radius of the first figure is 5. What's the radius of the second? 1/2 of 10, 5 also. All right. So 5 over 5 equals 1 over 1, means they are congruent. Okay, so they are congruent solids because they're in a 1-to-1 ratio. Bless you. Oh, by the way, the scale factor here is 1/3. Which one was, we should have written that these are similar. Yep. Now we're on to the page where it says 12.8 continued. Volume and surface area of similar solids. Okay, what I need you to get down from this is, if two similar solids have a scale factor of A to B, which is the same as the sides, okay, or perimeters, perimeter, side, scale factor, all are the same thing. That's A to B. Then the areas would not be the same. It would be A squared to B squared. And finally, volumes would be A cubed to B cubed. That's new today. We hadn't done volumes. All right, and that's really right here, guys. I just kind of rewrote it so you would feel it and do it. The scale factor is A to B, then the surface area is A squared to B squared, and any volumes A cubed to B cubed. Now, you can also go backwards. So if you're given the ratio of the areas, you take the square root, and that'll get you back to the scale factor. If you are given the ratio of the volumes, then you can take the cube root, which would be uncubing, to get the scale factor. And I'm going to show you how to do that on the calculator. Okay, I've got two spheres with the radii of 2 feet and 6 feet. What is the ratio of the volume of the small sphere to the volume of the large sphere? You will have a question like this on your final. If the scale factor, okay, of the radius of the small figure is 2, radius of the large sphere is 6. You reduce that and get a scale factor of 1/3. Now, the volumes would be in a ratio of 1 cubed to 3 cubed. We're going to figure that out now. 1 cubed means 1 times 1 times 1. 3 cubed means 3 times 3 times 3. You can do that way, or you can take your calc and you can say 1 to the 3rd, which I think is most of you, that's a waste of time to type, right? You know, anything times 1 is going to be 1. I mean, not anything. 1 times itself is always 1, no matter how many times. If you do, what was the other number now? I forgot. Is it 3? 3 to the 3rd is 27 because it's 3 times 3 times 3. Okay, so we got 1/27, and that's the ratio of the volumes. The numbers go up pretty big. Number 5, 2 cubes have sides of 4 inches and 7 inches. What's the ratio of the surface area of the small cube to the surface area of the large cube? This question could definitely be on the final. We've done these. If they have sides of 4 inches and 7 inches, then the scale factor is 4 to 7. Okay, now the areas then would be 4 squared to 7 squared. You know, you're supposed to evaluate that. What would that be? 4 squared to 7 squared. Square the numbers. 16 over 49. If you know your times tables, you can do that pretty quick. Now it says, what's the ratio of their volumes? Well, you still take the scale factor, and you don't square it this time. You cube it. Now these numbers are going to be rather large. 4 to the third is 4 times 4 times 4, which is 64. And 7 to the third is 7 times 7 times 7, which is 343. That's the ratio of the volumes. And if your scale factor is reduced, your ratio of your volumes will not reduce. Okay, let's try another thing with this. Two similar triangular prisms have volumes. Oh, so ratio of the volumes, 27 to 125. I want to get back to the scale factor. So here's what you do. You take the cube root of 27 over 125. You can do it all at once, or you can do the cube root of 27 over the cube root of 125. Now, you're going backwards. Instead of cubing, which means multiply something times itself 3 times, you're uncubing. So you want to go back to what number did I do multiplied by itself 3 times to get 27? And that would be 3. Now, I'll show you where you can get this off the calculator. And what would you have had to multiply by itself 3 times to get a 125? Just take a guess. Yeah, 5. There's only so many perfect cubes. So if you want to show how to do it on the calculator, here's what you do. Just have a look right now at your math button. Under math, the first thing's fraction, second thing's, I think, is a decimal. I never even used that one. This means to cube something. This means to cube root it. It's choice 4. And then if you had to do a 4th root or a 5th root or something bigger than 3, you can put in an index. You can put in another value right there. All right. So we need choice 4. But if I hit choice 4, oh, it's all ready to go. I just somehow messed myself up there. All right, math, choice 4. It's saying cube root of what? Well, we wanted to do the cube root of 27. So you can enter it like that, and that's 3. And you can do it again. Choice 4. And you can put in the 125, and it will do it. So there's where I got 3/5. All right, so the scale factor is 3/5. What would be the ratio of the surface areas, or any area would be 3 squared to 5 squared, so that's going to be 9 to 25. So you can go forwards and backwards with these. 7 says two similar rectangular prisms have surface areas of 64. Oh, that means I got the area ratio of 64 to 25. Find the scale factor. We would take the square root. The square root of 64 is 8, and the square root of 25 is 5. All right, now if you want to do volume, you have to cube. So I need to do 8 cubed to 5 cubed. 8 cubed is 512. Yep. So it's 512, and then 5 cubed is 125. All right. That is the end of the ISN. Now, where we need to go now, is I did make a shorter version of 12.6 for this year. Well, some years we just don't have as much time as others during a semester. Sphere, again, we already talked about, it has one basic measure of the radius. This is just a beautiful picture of the great circle, which is actually the biggest circle, which would be, what would this be on our Earth? Where's the great circle on Earth? The equator, yep. That's the equator. And then this is one hemisphere, and that's the other hemisphere. All right, so we've got our formula. You might just want to write down, we're going to do 4 pi r cubed divided by 3, and that's what it's going to look like on our formula sheet. I'll just do a couple of these. 1 and 2 are my only examples. So this would be 4 pi times 5 to the third divided by 3. Okay then. Sounds like a bird got into the atrium. Did you hear that? It's not a happy camper, probably. Oops, I forgot. Divide by 3. 523.6. That bird's going to be a little scared when school lets out. You think? All right, 2. We got volume. Now this time it's half of a sphere. So we're going to have to do 4 times pi times 16 cubed divided by 3. And then after we type all that, we'll hit divide by 2. Uh-oh. I just started typing it and I forgot to get out of my exponents. If that happened to you, you can hit clear and it'll go right back to where you need to fill in the 3. Then you got to arrow out, hit divided by 3, and then hit divided by 2. So you want to pay attention to what it looks like when you typed it on the calculator. Are y'all getting 8,578.6? Yes? Okay, 8,578.6. Did I divide it by 2? It's big. Yeah. Okay, cubic inches. All right, I think that's enough of that. You guys can type and practice typing it. Let's go to the 12-8. The new thing today about volume was if we have similar figures, we know about the ratio of their sides is A to B, perimeters A to B, area is A squared to B squared. The new thing was volumes are A cubed to B cubed. Okay. I will not read all this to you again. Let's check out if these are similar, congruent, or neither. First we check, oh, my mom's here. All right, so we got the heights. We compare and see. I'm joking. That was, remember how she made that sound. All right, we got ratio of the heights. There's 1 to 5. And what's the ratio of those base lengths? That's 2 to 10, and that reduces to 1/5. So they are similar. And the scale factor, SF, is 1/5. Okay. Number 2. Oh, well, what's the scale factor if they're both the same numbers? 4.2 over 4.2 is 1 to 1. You don't have that one, do you? I took that off. I made it shorter. You have this, don't you? 2 to 1. 2 to 1. But what's this one? 4 to 3. These are not equal. So not similar, which means that it is neither. Not similar or neither. Okay, that can happen. We did discuss that 2 similar solids have a scale factor A to B, areas A squared to B squared, volumes A cubed to B cubed. 2 cubes have sides of 3 inches. The scale factor, or SF, is 3 to 8. What's the ratio of the surface area of the small sphere to the surface area of the large? Well, area is going to just be 3 squared to 8 squared, and then you should evaluate that. That's 9 to 64. That would be your answer. You could have a question like this on the final. 6, if two similar solids have a scale factor of A to B, then the ratio of their surface areas would be A squared to B squared. And the ratio of their volumes would be A cubed to B cubed. Do I have that on your paper? We got two similar cones. They have heights of 3 feet and 12. The scale factor is 3 to 12, but you should reduce that. If you reduce that, that's 1, 2, 4. That's your scale factor. Now, what is the ratio of the volume of the small cone to the large cone? Volume would be 1 cubed to 4 cubed. We have to evaluate those. 1 cubed is 1. 4 cubed is 4 times 4 times 4. 64. That's the answer. All right. One more. Two similar triangular prisms have volumes of 125 cubic meters and 8. All right, that means the volumes ratio is 125 to 8. If you want to get the scale factor, you have to uncube. So we do cube root of 125 to the cube root of 8. Now let's use our common sense. What number times itself 3 times would be 125? Okay, what number times itself 3 times would be 8? 2 times 2 times 2. Yep, it is 2. Cube root of 8 is 2. If you know that, you can do these a little bit faster. You can actually type those again. I showed you how in the calculator. Does anybody need me to show it again? Cube root? No? All right, now, it said, though, what's the rate? Guys, we didn't finish the question. You do not need 2 minutes to stand at the door. What's the ratio of the surface area? You're not, what do you got to do to these? That's the scale factor. You got to square them. 5 squared to 2 squared. So we're going to say 25 to 4. Right, we'll review tomorrow and have a quiz on Thursday.